everybody, thank you for coming. I apologize, we do have a presentation today, but alas, technology was not working in our favor, so we are going to have to kind of rough it today and use the notes. I was lucky enough to have a little bit of time beforehand to jot notes down, so that way we can just have, jump off from there. Unfortunately, you're gonna have to just look at me and not at the pretty pictures. So, but full disclosure, they were just words on a page this time, so we aren't actually missing out on much. But welcome, I'm glad you're able to make it today. We are talking about environmental sustainability. So what is environmental sustainability to you? Does anyone want to say, what does it mean to you? To me, environmental sustainability is when you have cohesion of all of the systems working together to create a bigger, more fuller, well, you can't use sustainable because sustainable is the word that you're trying to define, but longitudinal balance. It's balance is what it is. Balance of systems all working together to create a bigger whole that makes life continue on, hopefully for the better. So that means on the planet, for environmental sustainability, we might look at the systems that are in play for the environment. So what do we have that has the environment kind of playing together and creating our ecosystem, our global ecosystem? Obviously there are so many different micro ecosystems everywhere, so but any feedback? What do you think? You can shout it out. Kind of quiet today, so our systems, we have environmental systems. We've got water, which entails when it becomes a gaseous state and it goes up into the clouds and then it rains down and it refills our bodies of water, which act as habitat and they work as the water systems work to keep life thriving, and without water we wouldn't exist. So our body is 90% water, so that's kind of comparable for many of the animals on the planet. So so it's very important to have our water systems working for us and continuing to keep the plant systems alive. And so for that, we have our 4 seasons. We've got, spring, summer, autumn, and winter. So, and that's when we have the replenishment of the plants and thus the continuation of life in that regard. So, and that looks different depending on where you're at on the planet as well, what those seasons are going to look like. In Minnesota, obviously, we have a winter. We have a real winter, although it's been very mild the past couple of winters. I would say I signed up to do snow removal two years ago, and there was no snow. I think we're out maybe 2 or 3 days. So hopefully that's not to do with global warming, but we're going to talk about that in a minute. So, but we have those systems in play with our plants. We've got the water systems, and then we've got our weather, just in general. There's a carbon cycle as well, which goes with, of course, the plants because of the carbon capture that goes with that. But obviously, carbon has a lot to do with things that we don't necessarily allocate to the nature category in general. So we've got those. Also, we've got basic things like food, shelter systems, and that kind of goes into play with if you are wildlife that is with nature primarily, and of course we've got other systems as well to take care of wildlife, but like from a human-centric perspective, but also we've got those systems in place for humans as well, which can be a little more dynamic and complex. And then we've got politics to kind of regulate that, religion to regulate that, education systems to regulate that. But we are just talking about environmental sustainability today. So we've got this, talking about systems. Let's break it down. Let's look at weather for now, weather and global warming, because that's a big one, a big buzzword. I know it kind of first became popular, I think when I was in school, it became exceptionally popular. The idea that, you know, the world is getting warmer. Do you guys actually know the nuances of what global warming actually means? Global when global warming is sorry global warming is when you have gases kind of going up into the atmosphere, and the greenhouse gases, and they are kind of clouding and making that atmosphere super busy and making it more difficult to sustain. The heat comes in from the sun, and it kind of bounces around instead of being reflected back out into the solar system and back out into space. So a lot of that heat is staying in the Earth's atmosphere longer. That's the theory. And so it's making it hotter because we've got so many particles, and when particles heat up, they go faster, and so it's just it's a big mess of gases up there, and we can't tell, you know. So that's kind of the theory behind global warming. All of the particles kind of bouncing around and making it busy, and making it hotter. The heat isn't escaping, and it's just feeding itself. And so you can look at weather with temperature, obviously, is a basic one. Wind, we've got dew points, we've got so much rain, the natural disasters, everything that is, all of those play into the environment, into the plants that thrive on the planet. So it's kind of a big deal to be paying attention to that. So thinking of global warming, breaking that down even farther, we can look at what our atmosphere is actually primarily made of naturally at any time, and that is normal atmosphere, nitrogen, oxygen, argon, a little bit of argon, carbon dioxide, a few other smaller amounts. And of course it's difficult to monitor this because with our wind, with the weather, obviously we have wind currents, and we've got ocean currents, and they're all spinning around consistently, and they can kind of change direction, and they've got basic directions that is the general trend. You can see this on a map, which I don't have available, obviously, because of our technology malfunction. but so I can't pull it up, unfortunately. But they all kind of work together in these ways to kind of have that normal atmosphere. I know when I first looked this up, I was surprised because as humans, we're told, oh, you need oxygen to breathe. You breathe oxygen. That's what we live off of. We need oxygen. And then just looking at the atmosphere, the actual makeup of oxygen is not actually that high up on the list. I know. So how much of what we're actually breathing is actually being utilized by the body? How much of it is actually being, brought into the lungs, brought into our bloodstreams, and what actually keeps our body going? So it was kind of a shock to me to see the numbers on what our system is actually comprised of. But greenhouse gases, there are a couple of big buzzword ones, carbon dioxide, obviously, methane, and some gaseous nitrogen compounds. I know when I was learning about nitrogen compounds, someone was giving me grief, and they were pretending like it was laughing gas, and that was in the atmosphere And I actually was like, oh, okay, that's fine. I mean, in small amounts, it's obviously not going to make us, but I was very gullible and naive to have believed so readily that it was the laughing gas that you would have at like the dentist office when they need to kind of put you out or put you under, or make you kind of numb to those things. So, oh, learning science, how exciting. I was a little cross when I saw the same gas with the 2 in the other spot, and it was like, oh no. Great, good. So I felt kind of stupid. So it's okay. That happens sometimes. But looking at these greenhouse gases, where do they come from? Obviously, there are a lot of different sources. It's a big world. There are a lot of different factors, but we can kind of look at each one separately. Carbon dioxide, the big ones, they would say humans, the populations, we breathe out carbon dioxide. We got carbon emissions from vehicles, carbon monoxide from vehicles, and we've got, let's see, just in general, fossil fuel usage. Then let's see, methane. Methane comes from agricultural spheres. Methane is obviously the gas when you fart. So agricultural spheres, they do have methane, and that can actually be a detriment to the farm animals if it is kept, if you don't have some sort of air circulation system in your agricultural areas. That it does contribute. It depends on, it's a big cycle, it's a big system. So, but that is a factor. Also, I read somewhere, and of course, I can't really verify any of this, just because I am just one person. I'm starting out on my environmental journey, and I do not have a lot of expensive equipment and a lot of professionals who just want to hand me an education. Thank you, nitrous oxide, laughing gas joke. So I think that is kind of something that you'll see around, unfortunately. But I did read that you can get a lot of methane from the melting glaciers. There is a lot of methane underneath the ice, and so as the ice melts, a lot of methane is released, comparably perhaps permafrost. That's another thing that you can kind of look at. Garbage dumps also have methane, so it comes about with some of the decomposition processes. Like in garbage dumps, I did watch a video where they have methane recapture initiatives in place, where they've got a lot of expensive equipment. I think they said, I can't remember if it was $1 million to set up the equipment, and they said, unfortunately, the amount of methane that you get from those structures do not actually, you don't get your money back. Like, they can sell the methane as a biofuel, but they don't get the money back. It's not a smart investment. So that's something that we could probably do some R&D and try and figure out a way to make it work more sustainably. For that, they had the garbage dump, and then they covered it over with the soil and the grass and what have you, and then they had the pipes coming up, and so the gases were coming up through the pipes and then going into this machine, this equipment. So that was the system that they had in place. But that might be a potential way a potential thing that you could look at to try and capture those greenhouse gases before they accumulate more and more and more in the atmosphere. There are huge initiatives in place for carbon capture. I went to an environmental presentation in North Dakota, and it was actually a full weekend, I think, of presentations where they were talking about this specifically, carbon capture, talking about trying to collect it and put it underground, and obviously we have the planting trees, and we'll talk about that in a second, but just different things. I've heard compressing it, direct capture. They were talking about one of the big chemical reactions with carbon is with calcium. So it said they're trying to look at the chemical reactions and how they can force those in a way that will take the carbon out of the atmosphere to try and reduce the numbers for molecules that are in the atmosphere. So that is what they're trying to do with the carbon capture initiatives. So that has been a big one for a very long time. So nitrogen compounds, nitrogen gases, they can come. Nitrogen is in pretty much everything, and then if things start to decompose, it's in the soil, which gets into the water, and so there's a lot of nitrogen just around. All the plant life is going to replenish the numbers, the amount of nitrogen. Poop has a lot of nitrogen, and it's good because plants need the nitrogen. So like that's where a lot of fertilizers will have nitrogen and phosphorus to get those numbers good, to kind of keep soil healthy for agriculture and other initiatives as well, I'm sure. But the amount is it's an exceptional amount of nitrogen that we are dealing with, and so and if you have a lot of nitrogen, then you can get this process called eutrophication, and eutrophication is where the nutrients are great, plants are thriving, and you start to get so many of them that they start to kind of block each other. The balance is thrown off. Like we said, environmental sustainability is a lot about balance, and so the balance gets thrown off, and you have this vibrant community, lots and lots of plants, and and then the eating is good for the fish, and so the different systems can also become abundant, but they start to block the sun from other plants, and everything starts to kind of fall down, everything starts to fail in the eutrophication process, and then everything dies. And you can see that in a lot of different water ecosystems specifically. So that is something to bear in mind for nitrogen, trying to manage it in a way. There are no-till systems for agriculture to try and keep the nitrogen, because when I read about it, it sounded like the chemical reaction is very, very fast and very easy for the nitrogen from the earth to get stirred up and then end up in the atmosphere, is what it sounds like. So they do have like no-till strategies that they can use to maintain agriculture. So a lot of different things are coming into play to try and mitigate the effects of global greenhouse gas emissions and global warming because of them. So of course, other initiatives, planting more trees, we already kind of talked about that, because they do provide more oxygen, which keeps that balanced, because we obviously, we went through those periods of industrialization, the Industrial Revolution, and we did not have our legislation in place to manage those numbers. So obviously not the greatest strategy, but we didn't know any better, so now we know better, and we've got our OSHA certifications and other all sorts of global certifications for maintaining clean systems in our factories and in business and just in general. So we've got all sorts of things like that kind of coming into play because of our oops with the Industrial Revolution. But trees give us more oxygen, they also capture more carbon, and then their leaves replenish the soil and give habitat to beneficial insects, and that's kind of another sphere of beneficial insects trying to replenish soil health, because if we do not have the fertilizer available, or if it's not necessarily healthy. We have a lot of runoff. That's another big ecosystem failing, is a lot of fertilizers, if not appropriately applied, can run off with the rain. It might go down into the water table. So that of course goes into the grander scheme of things, the water systems, which can kill off, we can get the eutrophication and we can see everything die. So no good. So we want to be mindful and conscientious consumers with the fertilizers. And so they're thinking bugs naturally will, eat decomposing materials, then they poop. We've got worm composting, we've got animal poop composting for the fertilizers, and so if we can manage those systems and find a way to keep them sustainable in ways that aren't going to have a lot of runoff, that would be ideal. So beneficial insects kind of take care of that. They might also eat bad bugs, and so they're a big part of the ecosystem. They're the largest class of animals, of beings, living things on the planet is bugs. So they're very, very, very important to the balance of life. Obviously, they get eaten by birds and things like that, and eaten by a lot of different things. So, so soil health, super important. Electric cars, another initiative. Electric cars, and also as well. I mean, electric cars do actually reduce the amount of greenhouse gases, carbon emissions that come from vehicles, that carbon monoxide. But also finding sustainable ways to power cars beyond the fossil fuels, which are, like, for example, solar panels and the wind turbines. And you do see a lot of those cropping up here in Minnesota, a lot of renewable resources. It's a big fad up here. And so, of course, our current administration is interested in, of course, the oil, fossil fuels, and that's a story for another time. It's good to have those resources as well, but I read somewhere that we can very much be running out of our fossil fuels. They are a finite resource versus infinite. So that is another element of sustainability on the planet, because we don't know how much we have. We've obviously been offshore drilling, and so I don't know. That's not my industry, so I don't know how much we're still bringing in. And obviously they've got the pipeline that also showed up in the news recently with Alaska to transport more oil as well. So lots of different things going into play with that, but it is not guaranteed there. I read an article that said they were pretty sure we were running out like 20 or 30 years ago. So it's, we're running out, but we never know when we're actually going to be out. They've got processes in place that they're trying to pull oil from the rocks, like surrounding, because it's underground and it's got its cavity there that so it's perhaps soaked into, been absorbed by its environs, and so they're trying to figure out how to pull it from the rocks to continue to use that and make fossil fuels still work. But obviously they are still used for a lot of virgin plastics, in healthcare, petroleum jelly. Petroleum is in the name, so mineral oil is also derived from fossil fuels. So we have a lot of things that are dependent upon those fossil fuels still. I know that they have come up with bioplastics that some of them are derived from natural ingredients versus the fossil fuels. That doesn't mean that they are compostable. That might still mean microplastics in the environment after, so that's something to take into consideration, but it is still very much a factor. Plastic bags versus reusable bags. Some places, cities are making it legislation that there is like a 20-cent fee, 25-cent fee, something to purchase the bag as well, to kind of deter people from using plastic bags, because it is all virgin plastics or virgin materials, which do come from fossil fuels. And we've got the microplastics, which I don't know if you know about the microplastic dilemma of plastics will, they say that plastics will never fully biodegrade because it's like Newton's law, like the molecules will always be there, and they only get broken down so much, so then we get the small amounts. We will have the small amounts regardless, and those get into the water systems, like when you wash your laundry, like the polyesters and the unnatural fibers, so you'll see that wherever virgin plastics have been chucked, or goodness knows, but they get eaten by the fish, and then the fish get eaten by birds. We eat the fish, we eat the birds. So who knows what the longitudinal effects of that are, and it's not going to be sustainable anyway because of our fossil fuel shortage, and it's just a better idea to think more sustainable in that regard. But that is an initiative that you will see. I have seen that up in Duluth. A lot of big box stores like Costco, they don't provide bags. You're buying in bulk, and so a lot of that wouldn't fit into a bag anyway. So these things are more sustainable. Speaking of buying in bulk, that does kind of go along with our initiative of zero waste. If you do buy in bulk, in theory, that can reduce the amount of plastic packaging. Packaging is a big thing, and companies are generally trying to make their packaging marketable, but also if they are being conscientious of the environment, environmentally friendly, and that varies depending on what their priorities are. Of course, you will still find things that have like 20 different layers of different wrappings, but if you buy in bulk, there might be less plastic involved, and there might be more. It depends on if you get the single servings or whatever. But zero waste is an initiative. You will see that. So they try to reduce the amount of food packaging that they consume. They try to ensure that a lot of things are not just going directly into our waste streams. And that comes down, that's the reduce, reuse, recycle of what we consume, what we buy, and what we sell. Trying to use secondhand items perhaps, or you just don't want to see it become garbage just instantly. If we can, it's closing the loop in our systems. So like with aluminum cans, there's actually not a lot of aluminum in like soda cans anymore, actually, from what I've read. Like soda cans, I think of them as aluminum cans. They're mostly magnesium, but they can be reused, and so the state will buy back those cans and then melt them down and reuse them. Of course, there are issues with that. There's going to be concerns with flaws with any recycling programs. Like there are different alloys, so from the top of the can to the side of the can, and things like that. So like if you're recycling concrete, concrete is a big industry that we can look at in way of environmental sustainability, but which I of course didn't write any notes on, but I've done a report for that for college, so I have done a little bit of research on concrete actually specifically. But the recycling process can be same with glass. Glass also can be, they're very hard materials, which means a lot of grinding, which means a lot of the equipment used to recycle them will face a lot more wear and tear, which means more replacing of those materials. And so if we can find sustainable things that we want to hold on to, that is probably going to be a better, more sustainable option. And yeah, housing sector, concrete is just the beginning. So there's a whole footprint with flattening and prepping land and the materials, if you fly them in versus finding perhaps upcycled materials or local materials, because shipping is another huge industry, which is why they suggest shopping local. Lots of things. Efficiency in appliances. I actually did an energy audit. I had someone from Minnesota Power come over to my apartment, and just because it was an older place, and so I wanted to see how much heat was going out, and like what my footprint was, just out through the walls, out through the windows. I had used the plastic on the windows, and they actually have programs in place where they can tell you that information. They can find out how efficient your systems are. And so they come over, and they actually were great, because I told them I was interested in solar panels, and they got me a lot of information about solar panels. And then they also said, we're here, this sort of work, this sort of advocacy, we are trying to help save the planet. So they said, hey, we've got these efficient light bulbs. Do you want some? We will literally replace every bulb in your house with the most energy efficient light bulbs. And so they offered me a shower head, and they said 5-minute showers. They had a little shower timer. And so I think their imperative is to make sure that we are sustainable, and some might argue it's our moral obligation to figure out how to find more sustainability in those appliances. Toilets, I did some research on toilets, because some of them still have 3-gallon tanks for water consumption, so you'll get 3 gallons down with every flush. Nowadays, it is actually law that you can only use 1.5 gallons, and you cannot sell a toilet that has more than 1.5 gallons in the tank. But a lot of those are grandfathered in, and the toilet does not need to be replaced yet, so it would be inconvenient to change those things. And but they, free shower heads, 1.5 gallons per minute shower heads versus X number of gallons per minute for water coming down in the shower. So there are lots of different little things that you can do, products that you can purchase or literally just be given to keep us more sustainable as the human race. There's also alternative diets like veganism, vegetarianism, to reduce the amount of agricultural strain for animals. And obviously agriculture is huge. You need to feed the animals with agriculture to get more agriculture, and the animals are the source of fertilizers, natural fertilizers. They're also the source of the meats, and they're also consumers of the vegetables. The fertilizer goes to the vegetables, so it's a big system, and you want to make that system sustainable. But it is generally suggested that, of course, the fewer animals that we need, the less agriculture we need to go towards animals. And there are a lot of, the world is getting better with more alternative options in way of foodstuffs. So as I was vegan for 5 years, I've been vegetarian for a very long time, so I'm very biased. But the market for vegan items is a lot better than when I became vegetarian in 2006. So it's definitely worth experimenting and at least playing with it. I mean, if you're interested in food in general, just try different things. So it's worth it to maybe try something new in that regard. So, and there are also diets where I'll eat a lot of fish, I won't do a lot of chicken, I won't eat red meat and things like that, or only, you can pick a day where you only eat meat and things like that. So this is the point in the presentation where I ask, what do you do to promote environmental sustainability? What do you do? Anybody? What can you do? I know I tried using an e-scooter for commuting, and it was so much fun. It was so much fun. It felt like freedom because it was like a motorcycle, except less fast, and it felt less dangerous. I was just like chugging along, and so that's something that I tried recently, and I would 100% do it again. The charge was not enough to get where I needed to go, but I was already figuring out how to get a secondary battery, or to make it last, so that way I could just go around town however I so chose. But it was so much fun. So that's a recent one. They've got e-bikes too. I chose a scooter because I wanted to try something else, and it had a cute little seat, so it was great. But that was something recently that I tried. Anybody? Okay. Well, that is wrapping up the presentation. Thank you again for coming. We do have seeds up here. Another thing is, obviously we talked about planting trees, but planting plants in general. We need the biodiversity. It is great for the planet. And we also, our natural spaces, we might be lacking in shade loving plants if, like, our understory in the environment, it might be a little sparse or neglected, especially in older forests, where the trees have just gotten so big. And so we do have seeds here that might contribute to the understory to help with those beneficial bugs, so they have something to eat and to live in and to thrive in. So again, more biodiversity, trying to keep our systems in place, and that's a whole nother science experiment. I am no expert. It's something I'm interested in, of course, but it's a great big world, and there are a lot of ecosystems, and so there are a lot of things that you can look at to try and make it a better place. These are available to be taken, though, if you want to experiment with them. So please do. Thanks again, and we'll see you next time. Any questions? I should ask any questions. All right, thanks so much.